Welcome to the second video dedicated to SPIRIT, the guideline for writing protocols. Protocols to change clinical practice, to decide, based on the evidence, which intervention is better. Let's begin. In a confirmatory study, we set the sample size to limit the risks of erroneous decisions. This process should be based on a main outcome, defined a priori. Let's see how to preset the sample size so that a study can act as a pivot in both directions, authorize or not an intervention. Controlling two possible errors: 1. Approving an intervention with zero efficacy, and 2. Not approving an intervention with some desired delta efficacy. The figure shows the distribution of the statistical test in these two alternative scenarios: 1. That there is no effect, 0, or 2. That the effect is exactly delta. Thus, the result of the study can take values along the horizontal x-axis. As there is some overlap between the two distributions, the decision cannot be perfect. The central line marks the threshold that will guide the decision. If the result is on the right, we will act as if they came from the distribution with the delta effect, and we will authorize the intervention. If it is on the left, we will act as if they came from the hypothetical scenario of no effect, and we will not authorize it. Thus, in most cases, we will adopt the correct decision, or if you prefer, we will control the risks of making wrong decisions. Thus, a small proportion alpha of studies on non-efficiency interventions will end with authorization, and similarly, another small beta proportion of those performed on interventions with the desired delta effect without authorization. Let's say that the complementary of beta is the power or the probability of authorizing an intervention with the desired delta effect. Increasing the sample size n will lead to more pointed curves and less overlap. And also in the case of numerical variables, less sigma spread, less overlap. This is the horrible formula that you should not remember, but you do have to know how to calculate the n. You need to know the values of the delta effect, the sigma dispersion, and the alpha and beta risks. Now you are able to interpret the sample size calculation for a confirmatory study with numerical response. You must specify delta, sigma, alpha, and beta. A full lesson of Greek language. Be careful, it is an important detail. The Greek letters represent parameters, values known in advance. Do not forget that you are in a confirmatory study, fed by the evidence of previous studies. Well, there is also a Latin letter, N, to represent the results of the calculation. Finally, it is important to know that you can work sigma and delta with the potential of experiments design to get the necessary power without increasing the number of volunteers. Which leads me to talk about the outcome. We distinguish between the main variable, which will serve to make the decision, and the secondary variables, which we will use to learn more to increase scientific knowledge. And that's all for today. Well, no. One final advice. Practice. Check in a sample size calculation that you can identify and interpret all these values. See you in the next video.